Completing the square is a method for solving quadratics. Although we can use it for any quadratic, we typically use it when we have an a value of 1 and the quadratic can't really be factored easily by product sum. So let's look at an example. We're going to look at 4 different ways you can go about completing the square of the quadratic y equals x squared plus 8x minus 10. So the first step is to set your equation equal to 0 because we're solving for x, right? We want to find our x-intercepts. In this case, we could add 10 to both sides. And then this is where the process of completing the square happens. When you complete the square, you're literally trying to force this quadratic to be written as a perfect square binomial. And we do this by taking half of your b value and squaring it. So we get 1/2 of 8 is equal to 4, and then 4 squared is equal to 16. So we want to add a 16 to the right side of our equation so that we can write it in vertex form. And since we add 16 to one side of the equation, we have to add 16 to the other side to keep our equation balanced. And when we simplify the left side, 10 plus 16 is 26, and then x squared plus 8x plus 16 can be written as x plus 4 quantity squared, and that's that perfect square binomial that we were talking about. Let's look at another way to solve or complete the square on the same quadratic. So again, we're going to set it equal to 0, but this time we're going to do the plus 16 minus 16 on the same side of the equation. So remember before we added 16 to both sides? But we can also just do plus 16 minus 16 on the side of the equation because that's like adding 0 to the side of the equation. So again, we took half of our b value, which is 1/2 of 8, which is 4, and then we square that, and that's how we get the 16. And taking the standard form right here, the x squared plus 8x plus 16, that's going to help us do the perfect square binomial x plus 4 quantity squared. And we still have this minus 16. Notice it's just basically what we have in method 1, and to make it look like that, we would just add 16 to both sides. And this is the step where you would solve by the square root method. This method is pretty similar to what we've done before, but it's going to be a little different if you ever had an a value that wasn't 1. So in this case, we're going to set our equation equal to 0, and we like to leave this blank on both sides because we're going to add something to complete the square to both sides of the equation. But this time we're putting these parentheses around our grouping and leaving this minus 10 on the same side it was already at. And we already know that half of 8 is 4 and that 4 squared is 16. So we're going to add 16 to both sides. And then we know that we can write it in our perfect square binomial. So we get this. And then again, we just solve it by the square root method. Again, this method is pretty similar to what we've seen before, but the way we're going to group the terms is something that might be helpful when you have a quadratic that has an a value that's not 1 that you're trying to complete the square on. So we're going to set it equal to 0, and then we're going to do the blanks to show adding whatever number we need to complete the square, but we have to subtract that out as well on the same side in order to be adding 0, right? Because we don't want to be changing the equation. We're just manipulating it to give us what we want. We already know that 1/2 of 8 is 4 and that 4 squared is 16, so we're going to add the 16 and subtract the 16 out. And now we can write the equation in our vertex form, x plus 4 squared minus 16 minus 10. And again, you can see that this is pretty much the same equation that we've gotten every time, and you would just solve this equation by the square root method now that you've completed the square. And don't forget that completing the square is a method to be able to get a perfect square binomial that can be solved by the square root method, and we usually do that when we have an a value that's 1 and it's not easily factored by the product sum. However, any quadratic can have the completing the square method done on it. It's just not always the best option.